Hi everyone, and welcome to this chapter of Dart Crash Course. In this chapter, we're going to talk about isolates. Isolates are a concept that is perhaps a little bit foreign to Dart and Flutter developers sometimes, especially when they get started, because things just flow so smoothly in Flutter, and you just create features and streams and work with them without having to worry about whether there are different threads created for you or not. But in fact, if you're really interested in Dart and Flutter development, then you should get to know how isolates work. So the way, I don't actually want to talk too much about Flutter, so let's not do that because this course is specifically designed for Dart. But when you create a Dart application and you create features and streams, then you have one isolate, and think of it as a thread. Even though if you debug a Dart application and run it, you probably see that there are like 8 or 9 threads running at the same time. So it's not just one thread running everything, but you have some sort of like an event loop, and things happen, streams like come in and features come in, and you just say await on this feature or await on this stream, and just things just move on so fluidly, and you don't have to worry about whether there's a new thread created for you. But the equivalent of creating threads in Dart is isolates. So isolates are usually functions that you spawn, or you create an instance kind of that function. And those functions have some sort of a port. So they're usually called send port. And the function that creates an instance of that isolate then creates a receive port. So the way it works is that a function that spawns a new isolate or a thread creates a receive port using which it can send messages to the isolate and receive messages from that isolate. The isolate then gets a copy of that port, but with that port, it can only send messages. So the isolate will pretty much just be limited to sending messages. However, there are ways of getting around that, in that you can create ports in an isolate that you can send messages and receive messages. So, but we'll go through them actually. I'll show you examples of how these things will work. So just for now, know that an isolate is kind of like a thread. And I kind of expect you to know that from before, what a thread is and how it works. So we're not going to go too much into details about what threads are. But just imagine that it's a thread that you spawn, you create an instance of, it does some work, and then you shut it down. That's it, okay? There are different ways of creating isolates in Dart than it is in Flutter. So in this example, since this example is a part of the chapter that belongs to the Dart crash course, we're not going to talk about how isolates work in Flutter, but the way I'm going to teach you how to create isolates is going to also be applicable to Flutter applications, okay? So let's get started. We're going to create a simple Dart project in here. Let's say Dart creates with a template of console. We say isolates like this. Then we're going to go into Visual Studio Code with isolates. Going to get rid of terminal. And then let's go in Visual Studio Code and say we have a zoom level. Like we usually do, we say zoom level of 6. And let's go ahead and delete this default bin file in here. And we say example 1 Dart, like that. Get rid of the Explorer, main, and then let's do an FS watch in here as well, okay? And we say example 1 like this. Good. So I'm gonna just show you an example of an isolate. So in this example, what we're gonna do is to create an isolate function, just a function, all right, that is able to produce like some messages. All right, just as many messages as it needs. It's just strings, okay, with the current date and time. So let's say we say void and we say get messages, and this is an underscore simply because I'm indicating that this is a private function. You don't have to call it this, but you'll see soon why we're actually calling it with an underscore. So let's just say underscore get messages, and in here, as I mentioned before, an isolate function should receive a send port using which it can send messages back to whoever created an instance of it. Okay, so let's say it's also an async function. Now, send port is something that is not just included in the standard library. So let's just go ahead and import it. So we say Dart isolate, as you can see in here. Okay, now in this function, then you have the possibility to do your work. So let's say that you want to produce a stream. Let's say we have a stream.periodic like this, and we say every, let's say, every 200 milliseconds like this. Let's break it down into separate lines. All right. We say const duration with that milliseconds, 200. And we say every time the stream ticks, then produce date time dot now, and then we convert it to ISO 8601 string. Okay. And then we say await for this stream, await for a final now in, like this. And you should already be familiar with the syntax of await for if you watched the previous chapter where we talked about asynchronous programming. So this shouldn't be like an alien syntax to you. Now that you have this, we have now as a string in here. So we want to produce this. We want to send it back to whoever created an instance of us. And the way to do that is using the send port. So we say sp.send. Okay. So, and then we say now. So this is it really. So we are producing a string that we're sending back to whoever creates an instance of us. Okay, so now we want to go and create an instance of this. So then it's going to be the entry of our isolate. So let's say the return value of this is a stream of string, right? Because you see this guy actually produces a lot of strings. It never stops. Okay, but we want to basically wrap this guy up inside another function that does actually produce a stream of this guy. So we say we have a function that produces a stream of string, and then we say we call it get messages like this. Okay, and you see this is basically like the outside nice interface for this function, because to consume this function you actually need to send it a send port. So imagine in your main function, all of a sudden you say, I want to call this function, but now all of a sudden I have to have a send port. How do I do that? Well, then we wrap it inside another function which does that for us. Okay, then we say, okay, we have actually a port. We want to send this guy a send port, but we want to receive messages from this guy as well. So in order to do this, this function that wraps this function has to have something called a receive port. So we say final RP as in receive port is a receive port. Okay, and a receive port has a send port. So we get a copy of the send port and send it to this guy. So we say we create an isolate first. We said isolate spawn using the spawn function. Okay, then the first parameter is going to be the actual function that is the isolate, and that it gets messages like this. All right, and then the second parameter is going to be our send port. So we say receive port dot send port like that. All right, so if you look at the result of this, you can see it is then a future of your isolate. Okay, so we want to somehow say, okay, this is a future, so we want to actually turn it into stream as a stream, which has only one value, which is our isolate. But since we have as a stream, then we have the possibility to work with this, if I say foo, as a stream. And in the previous chapter when we talked about asynchronous programming, we've already seen how, for instance, async expand works. Okay, and we've also seen how async map works. So now we have a stream of isolate. All right, let's turn this guy into messages that we receive from this guy. And those messages are inside this receive port, because receive port actually implements a stream. Let's go to receive port source code. You can see. So receive port is going to be a stream of the messages that this guy actually sends us. So if we could turn the isolate into these messages that come from the receive port, that would be great. So let's go ahead and say we async expand the isolate, and we say we don't care about the isolate itself, we only care about the receive port's messages. So we say RP in here. Okay, and if you look at the data type that we received in here, let's see, let me just break it down into separate lines so we see it a little bit better like this. And then if you say foo, you can see it. Oops, let's remove that and let's just move the mouse over it, and you can see it's a stream of dynamic. And it basically means really that is the stream of the messages that we're receiving from this guy. Okay, and to be honest with you, there's another way of doing this, and what we could do, we could just say create the isolate, and then like this, we could say, you know what, before I do that, let me just write this completely for us first, and then I'm going to show you another way of doing the exact same thing. So we say, okay, we are getting the messages back from this function using this async expand. So we're turning the isolate into the messages from that isolate like this. And then we say we are only interested in these strings. Then we say take while like this. We say element, and we say element is a string as long as messages are strings. And then we want to cast this. So we say cast it to like this. Okay, so if you look at the result of this, then foo is a stream of string, exactly what we need to return. okay? Then we say return that. And we don't then have to cast it like this. We could just say return, because then the casting will be applicable to the return value of our function, which will automatically then mean casting it to a stream of string, okay? So now we have our isolate in here. So this is the actual body of the isolate, and this is the helper function, which creates an instance of that isolate for us and receives its messages and returns those messages to us. But how do we consume it? Well, since this is a stream, we can turn our function into an async function and say await for final MSG in get messages, and then we only take 10 messages out of that stream. So otherwise, this isolate just continues indefinitely. All right, because there is no end to it. Then we print that message. All right, so let's just run the application and see what happens. There we go. So this is the date and time currently, and it is being printed with the intervals of 200 milliseconds between them. All right, so this is one way of creating this wrapper function. But if I want to write it in kind of like an easier to understand way for some people, because to me this is actually easier to understand, but for some people this may be like, oh my God, what is happening here? And if that is the case, if you're feeling like that, oh Jesus, I didn't understand anything happen here, let me just explain to you. This isolate spawn function creates, oh my God, it creates a future of that isolate. And you want to wait for this future to complete, right? So it's as if we say await, await. So we say final future is await on that isolate spawn like this. All right, and we can turn this function into an async function like this. All right. After doing that, then we wait for the receive port's messages. So we say await for, or actually we could say return receive port dot take while cast like this. Boom. So this is another way of writing exactly the same function, right? And this is the future. Oh, we don't have to wait for it like this. So, and then it returns the stream like this. Let's actually see functions marked with async must have a return type assignable to future. Try fixing it. Okay, well, it says that because we want to basically, we're doing await in here, we need async, but if we mark our function as async, then we have to return a future. So what we could do then is to go ahead and say this is an async function like this, and then we say await for this. We're casting it to, like, so it's a final MSG in like this. And then we could yield then our MSG like this. So this is another way of writing the same function. And this syntax should be familiar for you, this should be familiar for you if you've watched the previous chapter on asynchronous program. We've already talked about yield and await for, async, all of that, okay? But I find this code actually more difficult to have a look at or read than this code, because it is a lot less complicated, in my eyes at least, this guy. There's a lot less code in it, right? So, and also we had the return statement in here. So you can see it just says, create the isolate, turn it into a stream, but it is a stream just with one event of that isolate. And since that isolate, and when that isolate is produced, then just change the stream type to the receive port's messages, which are the messages coming from this guy, and then take those messages as long as they're strings, and then cast the result to a stream of string. That's it. It's so easy to read, to be honest with you, or at least in my opinion. Okay, that was the first example that we had. Let's just move on to the next example. We call example 2 Dart, and this is going to be actually a lot more advanced, I would say. Okay, and is an application that we're going to write in here. Let me just first create the main function, and then let's do fswatch, and like this. And in this application, what we're going to do, we're going to have some input from the user. So we're going to read what you say in the console, and I wonder actually if we can do fswatch. We probably can't do fswatch because we're reading input from the console, okay? So what we're going to do is to allow you to write some messages in here, and you say hello world, or hello, hi, how are you, whatever you want to type. And then we will have a map of responses. So we'll have a map of, actually I'll paste it in here so that I can explain how it's going to work. So if you don't say anything, and just press the enter key on your keyboard, we'll say, ask me a question like, how are you? If you say hello, we'll say hi back. If you say, how are you? We'll say fine. etc., etc. Okay, so this application is going to allow you to enter a message. Every time you enter a message, we'll spawn an isolate that will calculate a response and will send that response back to us. All right, and the whole point of this example is how do we create receive ports and send ports to communicate between an isolate's function and the wrapper function that actually spawns that isolate. All right, so let's go ahead and actually start creating perhaps this isolate for us. So let's say that we get started by creating some sort of a communicator function, which is going to be like the isolate core, the actual function that does a calculation. All right, so let's go ahead and create it in here. We call it void communicator, and as normal, as usual, we create a send port. In here, we have to accept a send port as a parameter, and we say this is an async function. Of course, send port is part of Dart isolate, so let's import that. Then let's think in here. Send port is just a vessel in order for us to communicate something back to whoever created an instance of us. But how do we actually know what the user typed? Okay, so somehow we need to send something back to whoever creates an instance of us in order to get a message back from them. Okay, so you see send port has no receive function. It just has send. So we can only communicate back information to whoever creates an instance of us. But how do we get the text that the user actually wrote in here so that we can process it? Well, there's a little trick that you can do. In your isolate function, you can create an instance of receive port and send your receive port to the originator. The originator being the function that creates an instance of us. Once you create your receive port in here and send it back to the originator using the send port, then you can use the receive port in order to receive messages from the originator. Okay, so let's say we have a receive port and we call it RP in here, receive port, like this, and we say the send port should send that RP like this. So whoever function that we have in here, so let's call that guy perhaps get message. All right, so we say we have a function that returns a future of string, which calculates basically, so this guy's response is going to be a string. So this guy should return a string, future of string, not a string. Because you see, every time the user types a message, we create an instance of this isolate. And that isolate would then respond with a string to us. Therefore, the result is a future, okay? And not a string. So we say get message. And we say there's the input to this function is the user's greeting. So whoever whatever the user types in the console, we're going to pass to this function, and this function is going to pass that to the communicator. Okay. We said this is an async function. As usual, the functions that wrap an isolate, they need to create a receive port in order to communicate with the isolate. So we say final RP is a receive port like this. Then we say that we want to spawn an instance of this guy communicator. So we say isolate.spawn communicator with the receive port send port. Okay, so let's just wait right here and see what happens. This guy has a receive port. Wherever you see the receive port, just think that this guy can both send and receive messages. Wherever you see a send port, just know that you can only send messages. Okay, so all right, we have a receive port, so we can send and receive messages. We give a copy of our send port to the isolate, using which the isolate can communicate stuff back to us. Then the isolate itself is saying, all right, I actually create a receive port using which I can receive messages from you. Because you see, we need to get this string here. This string somehow needs to be passed to this isolate. And without this kind of thing that we're doing in here, without this kind of communication setup, we won't be able to send this string to the isolate. So this guy says, I have a tunnel using which I can send and receive. And this guy says, then I get your send port, which I can communicate to you, but I also want my own tunnel. This way of communicating is as if I create a tunnel in my isolate and send my tunnel through your tunnel. It's a little bit strange, but it's a way of communicating between these two, okay? So this guy says, all right, you guy here, you get a copy of my receive port within your receive port, okay? So then we say, okay, Then we will turn this receive port into a broadcast stream because we're going to listen to it twice. And remember, we talked about broadcast streams in the previous chapter, so I'm not going to explain them again. So let's say we turn our receive port to a broadcast stream. So let's say final broadcast receive port is receive port as broadcast stream. Okay, then we want to wait because you see the first message that this guy sends us is its own receive port. Okay, so we want to get this guy. So let's say that final send port in here, okay, because the receive port is also a send port, I believe. We say we get a send port and we say send port communicator. Send port is await on this receive port's first message, like this. All right. We don't want to send the entire receive port, to be honest with you. We want to get the send port. So let's go in here and say this is a send port. We only send our send port back to this guy, so it doesn't have the receive port. It would be actually really weird if we did that. So let's say that this guy sends a send port back to us. And the reason is that using the send port, this guy can send messages to us. It shouldn't get actually a copy of our receive port. So that was my mistake, right? So we send, this guy gets the send port. Using its send port that it's received, it sends a send port to us, using which this guy can then send a message back to this, all right? And please remember, we're doing all of this simply because there is no other way to get this string to this guy. We can only get a send port to this guy. And this guy then has a tunnel using which it can send messages back to us. Then what better way of sending a message back to us than sending its own send port to us, using which we can communicate with it. All right, so we get the send port. All right, then what we're going to do is to say we send the greeting to this guy now. So we say, okay, we have its send port, then we send the for greeting message to it like this. So now this guy will receive that message from us. So what should we do with it? Then we say, okay, this receive port receives that message now. So we say final messages is the receive port. Remember, receive port is a stream. Then we say take while, all right? Then we say the element should be a string, all right? And then we cast it. We cast it to a stream of string. So now you can see this is a stream of string, all right? But we already know that we're only going to receive one message. You see, we're only receiving one message through this receive port in here. Okay, so even though this is a stream of string, but this guy won't make any assumptions about that. It will just say, all right, I have a stream of strings I have to process. Okay, so let's go through those messages. And remember, again, messages is this string. All right, this is this greeting, but we just assume it's a stream. All right, but this, as I said, this communicator shouldn't make any assumptions about the nature of this stream. It should just say, well, I have a stream of strings, I'm going to go through it. Okay, so let's say await for final message in messages like this. All right, then we say, okay, now that we have that, let's go for every message, which is a string. Let's go through this map. Then we say for final entry in messages and responses dot entries. Okay, so we're going through this map, and then we say if the entry, that key, by after trimming it, if trimming it and lowercasing it is equal to this message dot trim dot to lowercase. Okay, so just to be safe, we're trimming both the key, which is in here, and the message the user enters, simply because if the user says hello and then space, we want to be able to find that within this map. Okay, so spaces and all these white spaces should be removed from both the beginning and the end of the input string and the map. All right, so if the user says hello uppercase with spaces here and some tabs in here, and our map also includes this, something like weird like this, it still matches. All right, because we're removing all the white spaces. All right, we say, okay, if we found that entry within the map, then we say the send port should send this entry's value back to the caller. All right, and then we'll continue the loop like this. If we go through all these messages, which is going to be 1, and we actually didn't find any entry that matches the user's string, Then we go in here and we say send port should send. What should we say? I have no response. I have no response to that. Something like this. All right. So after this, we're basically jumping out of this loop anyways. All right. So good. Now we have something that seems to be working at least within the isolates body in here, but we have to go into this function because now we're sending the greeting, but we're not waiting for the result to come back. So let's go to the receive port because we received the first message, which was the send port from this isolate. So that is consumed now. Everything else that comes into this receive port, which is right here, okay, broadcast receive port, everything after the first message is going to be stuff that is coming in here, right? So just look at sp.send. The first instance got the send port, sent the send port to us, and we received it here. And everything after that is going to be the actual values that are coming out of this map. Well, let's remove this as well, by the way. So let's just say then the result of this future is going to be, let's say we go in here, we say return the broadcast receive ports, take while the element is a string, then we cast it to a string like this, undefined, okay, broadcast, okay, broadcast RP. So let's make it lowercase c as well, like this. Then we say cast it to a string. So it's basically the result of this is a stream of string. Let's say final foo. This is always something I do when I get confused with data types. I put it into a variable and have a look at the data type of the variable. Now I can see it's a stream of string. Okay, but we only want the first value because this guy should only send one value back to us. So we say, all right, we take that. We say take while, then we cast it. Then we say take one, just take one value out of this stream and then say first element of this stream. And the result of this will be a future of string. Okay. So we have that. Now what we need to do is just to go import Dart.io because we're going to talk with the user through the terminal. So we say Dart.io and we're going to have also Dart convert. So we say Dart convert. Okay. Like this. And let's see how we can use these. So in the main function, let's say that we do, and then we say while true, because we want to create a loop using which we can communicate with the user. Okay, so let's say std out.write, then let's say something like this. All right, and then we say final line. So we read the line that the user types. We say std in read line sync. And we say the encoding is UTF-8, oops, like this. And that's why we need Dart convert in here, okay? Because without that, you see, that UTF-8 is coming from Dart convert. Now we get the line, then we say we switch this line because it's an optional string. We trim it and we make it lowercase to lowercase like this with a capital C as well. Then we say after doing that, we say in case we get null, then we tell the user, actually we continue because, oops, what happened? Continue like this. So if the user doesn't enter anything in here, we get null. We then just continue the loop, in which case we just say something. All right. Then if the user types exit like this, then we will exit the program and exit the loop actually like this. We say exit. Actually, let's exit the entire program. Okay. And then we say in case of default, so if the string isn't null and the user didn't say exit, then we come in here. Then we need to create an instance or actually get our message from this future. Then we say final MSG is await on this. And then we send a line to it like this, unwrap it like this as well. And we print this message to the console. So let's go ahead and say Dart example. Where is it? It's in bin example2.dart. And you can see then it says say something. And let's bring our map in here so we can see it. These are the keys and values that we have. Okay. So if I just press the enter key in here, it says ask me a question like how are you, because it comes here, right? If I say hello, then it says hi. If I say how are you, It says fine. Are you having fun? Like this? Yeah, sure. And what are you doing? And if I say anything else that it doesn't understand, I say blah, 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 then it says I have no response to that because it hits this point, right? Okay, that was really good. So that was the second example in this chapter. I know things are getting more and more complicated with every chapter, but that's just the nature of programming. Things do get complicated. So, all right, we're done with example 2. And what we did in this example is, as you can see, for every time the user entered something in the terminal, we created an instance of our isolate. So because we call this get message function, and then this guy spawns a new isolate. All right, but this is not I mean, it's not so desirable because we're creating an instance of isolate just to get a string back, and it would be really good if we could keep this isolate alive while we're doing all of this. So we could just say we have an isolate and we'll just keep sending messages to it and we'll receive messages. For every message we send, we'll receive one message back. All right. And this isolate is going to be alive for the entirety of this program's runtime. And that's exactly what we're going to do in example 3. So let's close example 2 and let's say we have example 3 Dart main function. All right. And I wonder, let's just turn this into an async function. And what we're going to do then is to kind of like, let's go ahead and take the code that we did in the previous example. So I'm just going to keep example 2 in here. All right. And we're going to lift some code from here. So let's say we're going to lift the communicator. I think we need the communicator like this, and all the messages from here. Let's bring them into example 3 like this. And let's go ahead and import all of these as well, like we had in example 2, like that. All right. And then what we need to do, I don't know what happened with the take while, etc. messages. All right. This is fine. Cast. Okay. This seems fine. I think the code is fine the way it is. All right. But what we're going to do then is to go ahead and create some sort of a class that keeps hold of this this object for us, this how do you call it, this function basically, which is our isolate body. All right, so we're going to create this class and we're going to call it let's call it responder. We say class responder. Okay, now this responder is going to have some properties, and we're not going to create these properties right now because they're going to be a little bit confusing. I think if I just go ahead and create the properties, let's create the properties when we need them. Okay, so let's create a static function in this, because remember, this guy's responder is going to create an instance of this communicator function with isolate spawn. And then in here, it's going to hold that copy basically. Okay, it's going to hold that isolate within itself alive basically. All right, so we say we have a static future, which is going to create an instance of responder itself, and we call it create function. All right, so, and this is because Dart, again, this is one of the shortcomings of Dart. It doesn't allow you to create an instance of a class with an async constructor. So constructors are always synchronous. There is no async constructor. In order to create an async constructor, then you have to create some sort of a static async function that we're creating in here. So the goal of this function is to spawn this isolate and then save that information within this responder. And that information are going to be our properties in here, which we don't create yet because they will be too complicated to understand without actually writing this function itself first. So this guy is going to create an isolate, which is an instance of this. So we need our receive port. Okay, so we say final RP is a receive port, and then we say we spawn this guy, so like that. And then we take our receive port in here and we turn it into broadcast stream. And we do the exact same dance as we did before. You see in here, we say await on the first message, and this is going to be our send port. Okay, now in here, you can see, actually, this is writing the code that I wanted to write, but didn't exactly write it the way I wanted. And here, what do we need to save in this? Now that we've created the isolate, we need to kind of create an instance of this responder and return it as a result of our function. Okay, so we need to save the receive port, which is this guy. We need to save the broadcast receive port, which is this guy. And also we need to save this send port. communicator send port. Okay, so let's go in here and add those properties. So we say final receive save port is the RP, and then we say we have the final stream of dynamic, which is our broadcast receive port in here, and then we also have the communicator send port. So let's create a constructor for our class, and I'm going to say these are all required named properties or parameters rather, required like this. And then we go in here and create an instance. We say we create an instance of responder, and we say the receive port is the receive port, and the rest of the parameters we pass in here as well. So you can see we're creating an instance of responder and returning it from this future, basically. Okay. Now, within this responder, then we're going to have this get messages function that we had in example 2, like this. Let's go ahead and copy that. Boom, like this. All right. If I can copy the entire thing. Visual Studio Code is playing a little bit with me, that's fine. And then we go back to example 3 and we paste it inside this responder class. All right, so I'm going to go a little bit lower here and paste it within that class. Okay, now we need to change this guy a little bit because this get messages should not spawn anymore. Okay, so what we want to do in here is to remove this entire thing with the receive port, etc. Then we just send our greeting, which is this one, using our communicator send port, which is a property of the responder class. And then the result of this function is going to be broadcast RP, take while, cast string. Actually, this is nice. So broadcast RP, I wonder what the name changed to. Let's go in here and say broad. Okay, I keep misspelling this. Let's call it broadcast RP like this. And then the result of get message is exactly as we had before. So it uses the broadcast RP, take while, cast, take, and first. Okay. Now that we have that, we can go to our main function in here. And let's go to the main function of example 2. I'm just going to copy it and paste it in here in example 3. But we're going to make some changes. So inside this do, let's create a responder. So we could say final responder, and we say await on the responder create, and let's put this outside the do because we don't want to create an instance of this guy every time we go inside the do. Okay, then we say okay, std out, say something, or type exit, we could say, because exit is also valid input, right? And then we say we read the line as we did before, trim everything like that, and in here then we say await on the responder dot get message, and that's it. Really, that's the only change we had to make to this main function. Really, let's go and see if we can run it. So let's say example 3, and you can see it says say something or type exit, and I can just type exit and it exits the application. Or I can say hello, and it says hi, and I'll say how are you, and you can see it says I have no response to that. But didn't we have how are you in the list? Let's see. Maybe we messed something up. How are you? And it says fine. And let's say how are you? Now, did I type something incorrectly perhaps? And it says I have no response to that. Let's say how are you? Oh, I can see. So we've messed something up in here. It says I have no response to that. So it's like every other time it says the wrong thing. So if I say how are you? It says fine, and say how are you? It says I have no response to that. Okay, so let's have a look at what we may have missed in here. And I think what we need to do first is to go ahead and have a look at this message that gets printed to the console and basically remove this from here, because I think our loop really doesn't need that anymore. So let's go in here and then run our example 3 again, and let's say hello, oops, terminal, and let's say hello. Then we get hi, and we say how are you? And we get fine, how are you again? That should also be fine. And we say hello, and then we can say exit, and there we go. Okay, so this example built on top of example 2, but this time around we created an isolate and we kept it alive. And every time we get a message from the user, we then send that message to the isolate, which is still alive. So this reduces the cost of running this application dramatically, because we're not creating a new isolate every time the user sends a new message to us or enters a new message into the application. Okay, done with example 3. Let's remove that. And then we say, actually not remove it, but let's just close it. And we say example 4. And in here, we create a main function. Usually it's an async function when we're in these chapters, okay? And then we can clear the terminal. I don't think we need to do fswatch, but let's just see, okay? Now let's do a simple example in here. This time around, we're gonna do JSON parsing with isolates, okay? So we have some JSON, and I'll see if I can bring it to the console. Let me create a new window, and I'll bring it up in here. Sorry, I said to the console, I meant to the screen. So this is a simple JSON. You can see this is a JSON placeholder.typecode.com. And it just gives us some to-do items. And it's got these flags: user ID, ID, title, and completed. So we want to create an isolate that can basically grab the contents of this. We want to have the ability to download the contents of this URL, but have an isolate that can parse this content for us. Okay, so let's go and create an instance of our to-do class. So you can see it's got user ID, ID, title, and completed. So I usually create these very simple. So I say to-do, and then we say final int. Actually, we could say int user ID. So then you could say int ID, string title, and then you can say bool is completed like this. Then I go in here and I say these are final properties like this. And then I have the constructor created automatically for me in Visual Studio Code. Then I can say these are required named parameters like this, I believe, required. Okay. So that's done very fast. You don't need a third-party library to do all of these for you. And then you'll create a function in here. You say to do from, actually, this is a constructor. We say from JSON. We get a map of string and dynamic, and we say this is our JSON. And let's see if GitHub Copilot can complete this for me. There we go. And we actually don't have to do this. We can use an initializer list. We just say like this, and then we say these are equal to those values like this. All right. We don't need a constructor with a body, basically. We can just use an initializer list like this. Completed title, ID, and user ID. We can remove all these adds because the application will crash anyways if they don't match the data types that we are expecting. Okay, so this is a simple JSON model object. All right. Now that we have that, let's go ahead and create our actual isolate. And before I said that the isolate shouldn't download the contents, but I'm wondering a little bit, maybe we should actually do that. Let's have an isolate that not only parses the content, but also downloads the content. All right, so we go and create the actual body for the isolate first. Let's import Dart isolates, okay? Then we say that we have a void and we call it, a void function. We call it parse JSON isolate entry, and it has a send port, remember, SP, and we make it an async function. We create an HTTP client. We say a client is an HTTP client. And let's import, which library was it? Dart IO, I think. Yeah. And after having a client, then we're going to create the URL. I've already prepared that line, so we can paste it in here. So it looks like this. So this is the URI. Then we say, okay, go to the client and then get that URL, and which is our URI in here. Then we say we need to close the request. So this is the request. And I'm not going to be honest with you, talk too much about HTTP client because it's not so relevant to this chapter. In this chapter, we're going to focus on isolates. But I do have a lot of Flutter tips and tricks in which I talk about HTTP client, and you can find them on my GitHub repository, Flutter tips and tricks. And in here, we have to close the request. So we kickstart it basically. Then we use then, and we have to transform this guy. So let's just import Dart convert. So we're going to transform this into a UTF-8 stream. So let's say then we get the value, and this is basically our response. Let's say response, and we say response dot transform it. Let's see, response dot transform value transform expected. What is this response, by the way? Is this object? All right, it didn't really understand. Oh, because we have this null in here. Okay, and then we join it, so we get basically a string out of this. Then we say then again, and this is going to be our value. And then we say JSON decode like this, and we take the value in here, and we say this is a list of dynamic because the response in the browser is a list of dynamic basically in here. Okay. And then after that, we say then we get this JSON and we say JSON map. Every map should become its own to-do item. We say from JSON map to list like this. All right, actually, we don't need the to list in here, I would say. Okay, so the result of this is going to be, if we put it inside a foo variable, you can see it's a future of iterable of to-dos. All right, then we have that. We say final to-dos is await on that. So now we have an iterable of to-do. Then after that, we just say send port, send this to-dos back to whoever created an instance of us. All right, then we create we basically spawn our isolate within the main function directly. We don't have to have a some sort of wrapper function because it's a very simple application. So we say final receive port, or RP is a receive port. Then we spawn, we say isolate dot spawn. We spawn our parse with the send port like this. We've done that before many times now, so I don't have to explain it. Then we await for final to-dos in the receive ports messages. Okay, and we say receive port. Actually, let's bring it in here. We say receive port take while the element is an iterable of to-do. All right, and then we say then cast it to iterable of to-dos like this, and then we say we're only interested actually in the first one, take one. All right, so because we already know that this only is doing one send, so we just take the first message. All right, now that we have that, let's say to-dos is equal to that, and this is going to be then a stream of iterable of to-do. Then we say await for final to-dos in to-dos. Then we could just say print to-dos like this. All right, so if we go and run our application now, we say example 4. Then you can see we get instance of to-do, instance of to-do, blah, blah. And there are plenty of them, basically. You can always go to your to-do class and add a toString in here. So let's say override. I think GitHub Copilot is going to understand I want to do toString. Let's make it an arrow function. And we remove the return from here. And let's see, the default says to-do and it says user ID. I like to put parentheses around these like this. And like that, then we can run our application again. And instead of seeing instance of to-do, we're going to see some information. So you see it says to-do is a user ID 1, ID is 1, title is blah, blah, which is right here, and completed is false. Okay, there we go. So this is example 4, an example of downloading and parsing JSON right inside an isolate. Okay, let's close example 4 and let's go to example 5 Dart in here. And this example 5 is going to be showing you, this is going to be our last example in this chapter, but I'm going to show you how to spawn an isolate from inside a library. Okay, actually your isolate is going to reside inside the library, and then we're going to spawn it. So the isolate won't even be in here in this example. This is an example of running isolate from inside a library. As you've seen, when we create console applications with Dart, it creates a a bin folder and a lib folder. We haven't talked about this lib folder, but in this example, we're actually going to do that. So let's go into this isolates Dart in that, okay? And we're going to turn this, remove this function and create a main. All right, and we're going to say we get a list of args, but also we're going to turn this main function into an isolate by expecting a send port. So we say send port is an SP, and right here we just say SP, actually let's say message, and then we say message dot send hello world like this. All right, so then we have a main function and we have auto imported Dart isolate as well. And using this message send port, we're sending a message back. So now that we have this isolates Dart file in here in the lib folder, we want to create an instance of that isolate within our example. Okay, so let's go to example 5 Dart file and we say we have a main function. Let's get rid of the Explorer and turn this into an async function. And then we say first you need to create a URI. Basically, you need to create a path to that isolate. So since our project is called isolates, then the path is going to be a package. And then we say isolates and then the name of the Dart file, which is called isolates Dart. Okay, so we say isolates.dart. Okay, so this is the path. Let's just keep it. We say final URI is URI.parse. And then we place a path in here. Okay, then we say we create our receive port like we usually do. And now we also have to auto import this receive port. So let's say, actually not auto import it. Auto importing wouldn't require me to do it manually. Then we spawn that isolate with that path. So we say isolate.spawn, but this time we say spawn URI, okay? And in here, we're going to send it no messages. So no messages to that isolate. And then we're going to send our send port to it. And you can see using the URI, basically we're spawning an isolate. All right. Then we wait for the first message. So we say first message is the receive port's first message, and we await on it. And then we can print it to the console. And let's just run our application. So let's say example 5. And you can see in here, it just gives us hello world back. Okay. So just keep in mind that isolates are very easy to work with once you understand the basic concept of this receive port and send port. So if one thing you're taking away from this chapter, it should be that a receive port, if you see receive port, just know that it's a vessel to send and receive messages, as its name indicates. But when you see a send port, just know that it has the ability to send the messages to its originator. Okay? I really hope that you enjoyed this chapter. If you have any questions, please just join the Discord server, and we'll be more than glad to help you out. And I personally actually roam around in the Discord server. So any questions, just post them in the server. If not, you can post them also in the description, in the comments at the bottom of this video. But it's always easier to help people out in a Discord server than it is in the comments of a YouTube video. Really hope that you enjoyed this chapter, and see you in the next one.